All right, lesson 7.4 is all about right triangle similarity. So last week we talked about a bunch of different shapes being similar, and then we started focusing on specific triangles with the AA, side, 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 and side angle side. Okay, now we're specifically going to be looking at right triangles. Okay, so what I want us to look at first, we are familiar with this line. Does anyone remember what this is called? From a vertex to the other side, creating a 90-degree angle. Close. Everyone's been saying that. It's the altitude. Okay, I agree with you. It's perpendicular, but does it split this side in half? No. So this is specifically called the altitude. I want you to label that in your notes. So CD, this right here, that is our altitude. Okay. What that altitude does, and I would write this down. You can do this all on example 1. What this altitude does is it creates 3 similar right triangles. Okay. Whenever you see an altitude, that creates 3 similar right triangles. So the triangles they're talking about is they're talking about this big main one. Okay, and then they're talking about the 2 smaller ones. Okay, so those are the 3 triangles they're talking about, and they actually split up those 2 smaller ones so that you can see them separately. Okay. How these are similar is, do you agree these 2 triangles share angle A? They have angle A in common. You agree with that? Okay. What else do they have in common? That 90-degree angle. Okay. So that is similar to our AA similarity. If they have 2 angles that are the same, we can assume that they are similar. Okay. Would you agree over here that they both share angle B? Okay. And then what else do they have? The right angle. Okay. So this is also AA similarity, which is why all 3 of the triangles are similar to each other, just from that altitude. Okay. Jumping to example 2. Okay. Here, today we're going to be looking for missing side lengths. Okay. If I'm just looking at this right now, what are you guys thinking to find QR? Just looking at that first image up there, how would you find QR? What comes to mind? You're on the right track. Yep. We're finally coming to this today. Pythagorean theorem. Write this off to the side of example 2. Pythagorean theorem. Let's take some notes on this real quick. It doesn't necessarily introduce it as a main idea right now, but in chapter 8 is where it comes most in handy, but I'm just going to show it to you today because I think it's going to help you most with these problems. Okay. So, Pythagorean theorem, does anyone know what that is? A squared plus B squared equals C squared. That is the Pythagorean theorem formula. So, Pythagorean theorem, I want to label some things for you. What do this A and B stand for? Yep, those stand for the legs. So what I mean by legs of the right triangle is it's the ones that are connected to the right angle. Okay, those are the legs. What is the C? That's the hypotenuse. What do I mean by hypotenuse? It's the longest side, or it's the side that is across from that 90-degree angle, if you're struggling with which one's the longest. Okay, it's the side that is across from that right angle. Okay. So if I apply the Pythagorean theorem to find QR, here's the triangle that I'm going to work with. Okay, let's plug in where things need to go. What can I plug in for A? 12 squared, so you can actually do this on example 2. So 12 squared, don't forget the squared part, plus what can B be? 9 squared equals, what can we put in for C? You can use C squared, or a lot of us like to have X squared. It's whatever we're looking for. So now, when we get to this point, it's just evaluating. What's 12 squared? 144 plus 9 squared? 81 equals X squared. So now just combine these. What's 144 plus 81? 225 equals X squared. Now, to solve the rest of this, what's the opposite of a square? Square root. Yep, so I'm going to square root both sides of my equation. So then my answer, I get X equals, what's the square root of 225? It's 15. Yep. So what we got, which is what they already have in our picture right here, that QR is 15. Okay, one more thing I want to note about the Pythagorean theorem. You can only use this when, which is when right triangles. You can only use the Pythagorean theorem when you have a right triangle. Okay, if you do not have a right triangle, you cannot apply the Pythagorean theorem. So keep that in mind. Okay. So the next part here, I just want to do some different examples. How would I find what PR is? They were nice and they split it up for you. It's not always going to be split up, but let's look at it this way. How can I find what PR is? Could find QP first. Think of what we did last week. Can I set up a proportion between those two triangles? What's a ratio I can set up? 9 over 15 equals what are we looking for if we're looking for PR? It would be 15 over X. If we were looking for PQ, then we would do 12 over X. Yep. So to solve this, what's 9 times X? 9X. 15 times 15? 225. What's my last step here? Divide by 9. X equals, you get 25. So what we just found is that this missing side length that we were looking for is 25. Okay. Let's just keep working with this. How can I find PQ? Yep, I could do the Pythagorean theorem. What else could I do? I could set up ratios. Okay, when you get to problems like this where you could do both, I don't care which one you pick. Okay, either way you solve, you will get the same answer. So you can choose the Pythagorean theorem or you can choose the ratios. Which one do you guys want to do? I heard Pythagorean theorem first, and I like that because I want to show you a different way to use it. So here's the triangle we're looking at. And what is the Pythagorean theorem? Yep. A squared plus B squared equals C squared. What can I plug in for A? 15 squared plus, right, because remember the legs are connected to the right angle. And what is always across, or sorry, what is always C? Across from the 90-degree angle. It's our longest side. Squared. So now we just solved this. What's 15 squared? 225 plus x squared equals, what's 25 squared? 625. So now we solve. How do I get x by itself? Subtract 225 on both sides. So I get x squared equals 400. Last step. Yep. To get the opposite of a square, you take the square root. So we get x equals square root of 400 is 20. Okay. So that gave us our missing side here. Just to show you that you could have done it the other way. Okay, if you said I want to do the proportion route, how can I set up a proportion to help me find x here? We can do that. We can do, I heard 9 over 15 and 15 over 25. Do you agree I can do both of those? Both of them are true. I'll just do 15 over 25 equals 12 over x. Yep, so now we solve here. 15 times x. 15x, what's 25 times 12? Is it 300? Last step. Divide by 15. 300 divided by 15. See how you can get the same answer? Okay. When you have to decide between which one you do, I do not care. Okay, if you want to do the Pythagorean theorem just because that sticks out to you, do it. If you want to do the ratios, go ahead and do that. What you are going to notice later on is that when they don't split it up nicely like this for us into two different triangles, it might be easier just to see, hey, I'm going to use the Pythagorean theorem when we have overlapping triangles. Okay, but either way you solve it does not matter. Now we're going to talk about geometric mean. Okay, geometric mean is just another proportion that we're going to use in right triangles. Keep in mind, geometric mean only works in right triangles. Okay, so what this proportion is we represent it as A over X equals X over B. Okay, X being normally what we're looking for. Okay, what do you notice about this proportion that's a little different than usual? There's an X on both sides and they're across from each other. So when we multiply here, what are we going to get? X times X? X to the second. Okay, and then we get equals A, B. So to find missing side lengths in right triangles when we can't use the Pythagorean theorem, okay, we are going to use the geometric mean. Okay, an example for yours. Let's do example, you can do this one off to the side if you want to. So CD, it wants us to look for, what is CD? What's the vocab term here? That's the altitude, okay? We can use geometric mean to help us find the altitude. Okay, so to do that, remember we're following the A over X equals X over B. Okay, I'm looking for the altitude. Okay, so what I'm going to do is it compares what the altitude is a part of. Okay, do you agree the altitude is a part of two smaller triangles? Okay, so we're going to set up two ratios with that. So I can do 6.4 over X, because they're a part of the same triangle, equals, well, what does this formula say I need to set it up like? What has to go on the top? X has to go on the top over what goes with the other one? 3.6. So now I solve by cross multiply. 6.4 times 3.6 is 23.04 equals X times X. X squared, and then how do I solve this? What's the opposite of a square? Square root. Yep, so take the square root of 23.04. You get X equals 4.8. So what that gave us is it gave us our altitude. Now, we're not going to do it, but how would I find the measure of CB?
3.6.
How could I find the measure of CB? What could I do?
3.6.
Yep, what are you using, Lauren? Yep, you can use the Pythagorean theorem. Same thing if I was looking for AC, I could also use Pythagorean theorem also. Okay, what I want you to do is go try example 3 using the geometric mean formula, which is this one right here. Try and set it up. Okay, so looking at this again, we're looking for the altitude. Do you agree? CD is the altitude. Okay, so when we're looking for altitude, we're going to use A over X equals X over B, the geometric mean. Okay, so what's a ratio I can put together? 5 over X equals X over 15. Now, if you thought about it with these split up, okay, these ratios would make sense to what we've been setting up for a week now. Okay, they're the same ratios we've been doing. So if I solve this, what's 5 times 15? 75 equals X squared, X times X, yep. So last up, take the square root of both sides. What did you get for X? Some of you in your calculators got 5 squared to 3. What did others get? 30, what? 7.5. Okay, let me double check. Square root of 75. Yep. You should get X equals 8.66 or 7. Okay, when you do this in your calculators, I am not going to be picky how you round this. Okay, that's not what I'm testing you on. I'm testing you on, do you know how to solve the proportions and set them up? That's fine. Same thing. Yep. Same thing. If you told me this because your calculator gives you that, that's fine too. Cool? Okay. Part B says, describe how you can find the value how you can use the value you found for CD to find the other missing side lengths, such as AC and CB. What could you do? Yep. You could use the Pythagorean theorem for both of them. Now, yes, you could set up proportions, but I do think it is easier when it's in overlapping triangles to use the Pythagorean theorem just to see the difference. All right. I want to look at this example next. It's not in your notes yet, but it's very similar to your example 4. Okay. We are still going to be using geometric mean, which is that a over x equals x over b. This geometric mean, the main focus for it is to help us with the overlapping right triangles. Okay, if they were split up, these are the exact same ratios you would be setting up originally. Okay, but this geometric mean helps us when the triangles are overlapped. Cool? So now I want to find RT. How can I find RT? Don't look at this, it's cheating. What are you guys thinking to find RT? Right, are some of you thinking, well, I should find this first, and then I could use Pythagorean theorem? Okay, there's an easier way. Okay, what we're going to do is we're going to set up a proportion, and we're going to look at the total hypotenuse length for the whole thing. What is that total length if I add those together? If I do 9.6 plus 5.4, I get 15. So my geometric mean is 15 over x equals x over, what do you think should go here? Okay, this x is a part of this triangle, do you agree? What's the other number a part of that triangle? 9.6. Let's put that in the same color. 9.6. So now if you're comparing, here, 15 is my hypotenuse, do you agree? Is x my other hypotenuse of this triangle? Yep, so it's the same thing. And then these were my legs. Okay, so they're the same proportions we're setting up, but it's just using the geometric mean with the overlap. Okay, so how do I solve this from here? Cross multiply, yep. What's 15 times 9.6? 144 equals x squared, and then our last step, take the square root of both sides, so we get x equals 12. Okay. How would I find ST? I could use Pythagorean theorem because I would know this whole side and this whole side. I could use Pythagorean theorem. Could I also do another proportion? Yeah. Yep, I also could. Okay, I want you to go try example 4, A and B. All right, first thing we want to do on example 4 is look for JL, which is this side length here. So remember, when we're looking for the side lengths that are not our altitude, okay, we want to combine our whole hypotenuse. Some of us forgot to combine the whole thing. What's the whole thing? 24 over x equals, yep, we want x over 4. Why do we pick 4 and not 24? Because 4 is on the same triangle. Right, it's on the same triangle as the x. Okay, so now I solve, what's 24 times 4? 96. I don't know why I put an 8 there. 96 equals x times x. X squared, last step. Square root. X equals 9.8. Again, as long as you're in ballpark range, you're good. Okay, so our missing side for JL is 9.8. How do I find KL?
I just put it instead of 4, put 20.
Yep. How many of you used Pythagorean theorem? Some of us did. Okay, let's do the proportion route first. What somebody said is they just substituted this for 20. Is that what a lot of us did? It's the same thing. Yep. We can do 24 over x equals x over 20. Well, what's 24 times 20? 480 equals x times x. X squared, last step. Take the square root. So we get x equals 21.9. Those of you that use the Pythagorean theorem, did you get the same answer? Yes? Yep. Just so we can talk about it, let's set up the Pythagorean theorem. We won't for sure solve. If I use a squared plus b squared equals c squared. Now we're looking at this whole triangle here. What is my a squared? What can I put in for a? 9.8 squared. What can I put in for b? Right, b squared or x squared. And then what's my c squared? 24 squared. Yep, remember, biggest thing when using the Pythagorean theorem, this number right here has to be the side across from your right angle. Has to be that longest side. And if you solve this, you would get the same thing, x equals 21.9. Example. Don't look at the answer, that's cheating. Okay, here, it wants us to find the value of x. Okay, what I want you to notice that is super helpful. If it gives us the altitude, that's one step ahead already. Okay, so if I use the geometric mean, a over x equals x over b. Okay. Okay, I know my altitude. What do I not know?
The full length of the bottom.
Right, I don't know what the x value is or either of these side lengths. Okay, so that's what I'm going to plug in for my a and my b. Okay, so I'm going to do x plus 5 over my altitude, which is 6, equals, my altitude is 6 over, what's the other one? X. Okay. So we solve, what's 6 times 6? 36. What happens here? We talked about this on day 1. Right. Think of this as parentheses. So this turns into x times x plus 5. What do I need to do on the right side? Some of you already said. I need to distribute, right? X squared. Yep. So I get x squared plus 5x. Looking here, we normally solve for x, right? Is it easy to solve for x right now? Because we have this x squared and we have another x. Yep. It's the big F word, but it's not the first one that comes to your mind. Factor. Okay? We are going to factor. Now, let me erase my little scribbles here. So we have x squared plus 5x. When you factor, we need to do something first before we can factor. We have to get it equal to 0. Trick for that is you always want to keep that x squared positive. Okay, so how can I get this equal to 0? What do I do with this? Yep, take 36 over. So I'm going to subtract 36 on both sides. I have 0 equals x squared plus 5x minus 36. All right, now we are in factoring terms. I want to look for factors of negative 36. So two numbers that multiply to get negative 36 and add up to get 5. It is 4 and 9. Yep, I need to switch those though. Okay, so what happened here? Negative 4 times 9 gives me negative 36. And negative 4 plus 9 gives me a positive 5. Anyway, once I have the factors here, how do I write those as factors?
X minus 4 times x plus
Yep.
Ain't no way to mention that.
The step I did there was I just wrote them in terms of x.
Oh, okay. Yeah.
Okay? Now you're to the easy part. What do I do from here?
so you make x equal 0.
Yep, you set both of these separately equal to 0. Okay.
This is like the worst thing to do. This is like the last thing I learned.
So now you just want to get x by itself on both of them. I'm going to add 4 over here. X equals 4. And I'm going to subtract 9 here. So I get x equals negative 9. Now, we have two results. Which one is our answer? Let's look back at our picture. If I look at this x value, does it make sense for that to be negative 9?
No.
Why not?
Because you can't have negative measurement.
Right, there's no such thing as negative distance. Okay, so I know negative 9 cannot be an answer. Does it make sense to have 4 here?
Yeah.
Yep, because it's positive, we're good there. So our x value is 4. Okay, so if I plug that into my diagram here, this side length is 4, what's this one? 9. Now, to your actual problem, how can I find, let's start with the value of y. How can I find y? I can use Pythagorean theorem,
Or the what's it called? Ratio.
or I can do the proportions. Okay, like I said, when you get to problems like this, where it's the overlapping triangles, I do think the Pythagorean theorem is going to be the easiest for you to set up. Okay, so let's go through how to set up the Pythagorean theorem. What is the Pythagorean theorem? A squared plus B squared equals C squared. So I'm looking at this triangle here for Y. What can I plug in for A? 4 squared, B can be 6 squared equals C squared or X squared, whatever you want to do. Because Y is my hypotenuse across from that right angle. So solving, what's 4 squared? 16 plus 36 equals C squared. What do I get when I add those two together? 52 equals C squared. Last step. Square root. So C equals 7.2. So that is your Y value in your picture. So if I go back, 7.2. Last one. How can I find Z? I can do the Pythagorean theorem, okay? Here's the triangle that it has to do with. Okay? A squared plus B squared equals C squared. What can I plug in for A? 9 squared plus 6 squared equals C squared, Z squared, X squared, whatever you want to do. What's 9 squared? 81 plus 36 equals C squared or X squared, yep. What's 81 plus 36?
117.
117 equals C squared. Last step. Square root. So we get C equals 10 point what? 10.8. That's your Z value. So this one was Y. This one was Z.